Hello, my name is Angie, and here I'm going to present what I presented at the EVDS mini-conference at the University of Calgary in March 2018. It was just a small conference, and essentially this talk is still sort of a basic draft, but I'm going to share it here so that you can know what I talked about and also so I can remember in the future what I said. So the talk was called Analyzing Location Tracking Data in Studies Relating Green Spaces and Health Outcomes. So for this talk, first of all, I'm going to do an introduction about using location data in design. Then I'm going to talk about why I chose to focus on the topic of analysis. And then I'm going to present a literature review which shows analysis methods in studies using human tracking data. And then I'll also show just how I group a bit about how these three themes that I grouped the results in, which were regression modeling, visualizations, and mixed methods. So the overall concept that I want to share is that using spatial data in design is not new. Designers often present graphics showing human movement paths or floor plans, site plans, or maps, and they're illustrated over proposed designs or otherwise on an existing design. And the purpose of this is to analyze the plan in order to make improvements, or sometimes also it's done to study a precedent. But within doing this, there's this intrinsic idea that if we study how people use spaces and move through spaces, we can evaluate that design and potentially design it better. So designers drawing arrows, when they're doing this, it's their own approximation of what they expect people will do. So essentially, they're making a prediction about human behavior. So there are also scientific methods for making approximations and predictions about how people will use and move through space. And doing this usually requires lots of data and some sort of predictive statistics. So one famous historical research project for using spatial data in design is William White's work in 1969 in New York. So this project is famous because the outcomes of the study were used to create a document of design recommendations for public plazas in New York, and the outcomes had a major impact on the experience and feel of the city for generations. So this study used multiple ways to collect information. One way is that the researchers stood on a nearby roof, and through video cameras and also their own observation, they recorded many hours of video that showed where people were located in the urban plaza. So then the researchers translated this data onto graphs and maps. One representation of this is they created a grid and posted places that people stood. They mostly used visual analysis of these graphics and maps to portray their findings, and this is partly because of the amount of data that they had shown and the type of things that they wanted to show and could be shown visually. So another method for using spatial data in design is called behavior mapping. So Henry Sanoff developed this method a long time ago, maybe in the 1970s, and it's been used a lot with children to evaluate play spaces and other types of spaces. So the method involves recording a location of a child or a person at a specific time interval, and also at the same time that you record their location, you also record what behavior they're exhibiting. So the analysis method most often used or commonly used for this is some sort of correlational statistics, and it shows if there's a common pattern or perceivable relationship between a behavior and environmental feature. And this is useful for when you're comparing two factors. But as we know, in the last 20 years, there's been a surge in new GPS and location-based technologies, which means that a device can record where people are without researchers having to be out there watching 24 hours a day. So for example, in this study where they're looking at urban green spaces and children's physical activity, they strapped GPS devices onto a children's wrist and also an accelerometer, which measures how their physical activity. And they used the GPS to collect the location data. So the results you can see from these maps, it shows the presence of different levels of physical activities in a park or in their neighborhood. And they can also use correlational statistics to determine if there was a consistent pattern in relationships. So why is analysis so important for this? Well, with GPS data, the collection of data has gotten easier, but analysis has become harder. Some of the challenges are that the data sets are quite large, the data can be noisy, the data can have accuracy errors in it. You also require computational skills to analyze it, and it's also, this type of analysis is not usually within the domain of typical design education. But analysis is key, and it's also difficult. So we may have all the right data, but if we're choosing inappropriate analysis method or applying it poorly, it can result in large and impactful errors. So to provide a little help in this topic and some clarity about analysis, I decided to do a literature review to see what analysis methods had already been used. So to collect some literature, I searched up green space and GPS and health and tracking, and I also mined these bibliographies for relevant papers. I also used some review papers. So this is not really meant to be representative of the field, but to give me a sample set to explore the range of different analysis methods being used. So the most of my papers that I collected were published in 2016, but they ranged as far back as 2008. So the analysis methods used most often in these studies, the largest method used, or the most often, was regression models, second was descriptive statistics, and third were visualizations. And many of these studies used a combination of methods. So I grouped these into 3 different categories. The first one was forms of regression modeling, second were visualizations, and the third group were mixed methods. So regression models. Here I'm just going to give a real quick brief intro into regression modeling and why it's useful for this type of data. So regression modeling is a set of statistical process. It's a mathematical formula that allows you to see the effect of various variables on a measured outcome. So for example, if this was your data set and you had collected in the highlighted red MVPA, which is an acronym for or a type of categorization of physical activity. So you've grouped them into 1, 2, and 3 for their different levels. And you want to find out the effect of all these different parameters or elements on the physical activity of children. So with each point you've collected, at the moment you collected it, you collected their physical activity, but you also collected how close they were to a green space, or let's say how far they are from home, or say the tree density of the green space. You could also have collected what time it was at. And so you can put, these are all just for example, but you can put all of these into a model or a formula in order to see the effect of these variables on the outcome. So the type of thing you might be thinking about is there a large effect of being close to a green space on people's physical activity level? So some of the pros of regression modeling is that it's a well-established statistical method. It's used across many research fields, and it helps you find patterns in the data that would be impossible to find other ways. Some of the cons of this method is that you have to know statistics and have some computation skills. It can be hard for non-experts to interpret, and sometimes this can result in distrust or misreading of the results because either the researchers or the people you're trying to explain it to don't understand. Okay, so of the papers I collected, 11 of the 24 papers used regression models. So for example, here's one paper where they did a regression analysis of children's physical activity, and they found that children exposed to green spaces for more than 20 minutes a day engaged in nearly 5 times the daily rate of physical activity over children with 0 exposure to green spaces. And then they mapped their results, and you can see pretty clearly the yellow spots is sedentary behavior, and that's at home, and then they're more active in the nearby park. So another method of analyzing the data is through some sort of visualization. So this way allows people to actually see the patterns for themselves. It can also allow people to explore the data and see a relationship. And sometimes even the output of the statistics can be in the visualization, and that allows people to see the results without having to understand the statistics behind it. So GPS is what's called spatial temporal in that it includes time data as well as location data. And portraying both changes in time and location in one graphic can be very difficult. So you can see below, this shows clusters of activity for GPS users, but it's not shown over different changes in time. One solution for this is something called a space-time grid, or here is also a space-energy grid. So this is where you plot where the person is on the XY axis, and then use the Z axis to show the time of day, or otherwise what amount of energy they are putting out. But this is okay if you have one participant, but very hard if you have from many participants at once. So one example is to use interactive on a computer generated interactive visualizations. So here's one called a life log, where they use a heat map and graphs to show physical activity collected from accelerometers and also GPS data around the city. So they incorporate heat maps, but they also incorporate these kind of graphics that you can scroll through and click on in order to start to see how the different times of day are changing and how much more complex elements are like factors in the environment and stuff are affecting how people are physically active. The truth of the matter is, though, that large spatial temporal data from multiple users is really hard to show visually, and currently there's no really satisfying visualization methods for this types of data yet, but it's very exciting because it's at the vanguard of visualization research domain. And then finally, talking about mixed methods. So for example, so mixed methods usually are less established methods, but they can incorporate different types of data, quantitative and qualitative methods. So this is a really interesting study by Bell and al. So they investigated how people used a trail system in a linear green park. So they gave participants GPS and accelerometers for a week. And then they collected that data and created their own sort of GPS maps showing how people were using the park, and they analyzed these quantitatively. And then after they generated these maps, they decided they went back to the original participants and conducted interviews based on the maps to get more information about why these patterns might be occurring and what the people were thinking and doing at different points on the data. And then they made new maps incorporating all this information. Another example was done in Britain, where they had 20,000 people download an app on their phone, and the app asked people at various moments of the day how happy they were on a scale between 1 and 100. And then they also collected on the phone the location data simultaneously, and then later they compared how happy people were to their location. So they used a regression model to determine what land cover types were related to people's happiness. And by the way, they found that people were happiest outdoors in various natural settings over urban and indoor environments. So in conclusion, I presented 3 themes to describe analysis methods using GPS data to relate green spaces to health. So I talked a little bit about regression modeling, which enables researchers to incorporate multiple variables and also evaluate large data sets and identify generalizable patterns. I also talked about visualizations, which enable non-experts to visually see the data, but there are challenges with larger data sets and multiple variables. And then I also talked about mixed methods, which can be diverse and maybe not as established in the literature, but offer the best promise for future work that looks to apply these data sets in design practice.